Hi, the 8 basic laws of indices. Laws are also known as properties or rules. So let's look at 2 of the 8 laws. Law number 1, that's the product law. Alright, this states that a to the power m times a to the power n is equal to a to the power m plus n. Alright, where a is a real number but not equal to 0. So m and n are integers. They can be either positive or negative. So now we know that the base here is the same. So whenever you find the base being similar, the product must have that same base, and the index must be the sum of the two indices. That is to say, we have a here and there, and we have the index m and n. These are two different indices, and then when you multiply these terms, they will give you this base here. Because these are similar, therefore you write the same base here and then add these indices. So practically this means, let's write 2 to the power 3 times 2 to the power 4. This will give us 2 to the power 3 plus 4. Do you see? This base is the same as that base. And because this base is the same as that base, therefore the product will have the same base. And the indices must be added together. So this will give us 2 to the power 7. All right? So what does 2 to the power 7 mean? It means 2 times 2 times 2 times 2 times 2. Let's count them. 1, 2, 3, 4. 1, 2, 3, 4, 5. Well, not yet. Times 2 times 2. So they are 7. So 2 is multiplied by itself 7 times to give us a number. We haven't arrived there yet. So what is that number? The number is actually here. But to be explicit, we have 2 times 2, which is 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2. That will give us 128. So actually, 2 to the power 7 is equal to 128. So you can write this way or that way. But somehow, this format facilitates us to make certain calculations. All right, so number 2 law is the quotient law. And this law states that a to the power m divided by a to the power n is equal to a m minus n. What does it imply? If you divide a to the power m by a to the power n, that will give you a to the power m minus n. So that means the base up there is the same as the base below here. And when you find such indices which exponents are different, like say in this case m and n, so all that you can do is write the base here and then subtract the index of the denominator from the index of the numerator. So we have m minus n. So this implies that a to the power m is being divided by a to the power n. This is the case only if the base is the same. It's the case only if the base is the same. So this also means a is not equal to 0. And a is a real number. M and n are either positive or negative integers. So next, we are going to give a practical example. Let's say 3 to the power 3 was divided by 3 to the power 2. So what would be the answer here? So what we'll do is, we say 3 to the power 3 minus 2. So that's what we would do. And this will give us 3 to the power 1. And 3 to the power 1 means 3 cannot be multiplied by itself any times. So it will just be there. So all we need to write is 3. Okay? So in other ways, I'll prove to you how this occurs. So we have 3 to the power 3 divided by 3 to the power 2. So this implies 3 times 3 times 3, okay, divided by 3 times 3, okay? So all we can do is just cancel here, all right? Simple mathematics, you know, this will cancel out. So what we'll have is 1 here, 1 there, 1 there, 1 there. So 3 times 1 times 1, that will give you 3. And then here we'll have 1 times 1. So 3 divided by 1. All right, let me just write it down. Okay, write it down here. This will give you 3 over 1. So you divide 3 by 1, that will give you 3. So that's the meaning of all this. So next we'll look at other laws, all right? So in the meantime, please subscribe, like, and share. I'll be grateful. Thank you.